All right, we're going to pick up with this one. I think this one's actually your number 4 on your worksheet if it was updated. So it was missing on here, but we have this function. Now we have x cubed. We're missing x squared. We're missing the x. So we have some terms missing. If I was to write this top one out, it's really the same thing as x cubed plus 0x squared plus 0x minus 1 over x minus 1. Okay, so if it has a term missing, you have to use 0 as a placeholder. And if you make mistakes in synthetic division, that's probably where your mistake is made. Now we're ready to drop the coefficient. So I'm going to 1, 0, 0, negative 1. And then because this is in this format, I'm going to put positive 1 here. And then we'll start this process. Drop the first. Multiply, 1 times 1 is 1, add down, 0 plus 1 is 1. Multiply, 1 times 1 is 1, put it in the next slot, and then add down, 0 plus 1 is 1. Start over, multiply, 1 times 1 is 1, add down, and we get 0 is the remainder. Okay? Now, if the original polynomial was x to the third, which is a third degree, then I start here with 1 degree less, so it's x squared plus x and keep going. So this is going to be x squared plus x plus 1 and no remainder. The next thing we're going to look at is the remainder theorem. It says, suppose you have a polynomial and they give us the number c. If we evaluate p at c, then we can learn something about the remainder. Now what we're going to do is we're going to evaluate p at c. So that means I take my original function and everywhere there's an x, I'm going to put a parenthesis. 2x plus 1. So I'm taking this polynomial and everywhere there's an x, I put a parenthesis. And now I'm going to go back in and substitute negative 1 in place of it. Negative 1 cubed is negative 1. Alright, negative 1 squared is positive 1, and positive 1 times a negative 4 is a negative 4, minus 2 plus 1. And that would add to give us negative 6. Now, the beauty of this is if I was to take this exact same polynomial and do synthetic division to it, we want to know if the remainder is in fact negative 6. So I'm going to pause this for a minute and go do some scratch work to the side. Wow, well look at that. If I use synthetic division on this polynomial and using this term, now specifically they told us c is negative 1, so I use negative 1, and did synthetic division, then we see that the remainder was the same thing as what we got when we evaluated p of c. And that's exactly what the remainder theorem is claiming. So when we need to know what's going on with the remainder, we also have the option of using our remainder theorem to give us an idea of those characteristics. Alright, so for part B it says, plug this in, evaluate p of c. So everywhere there's an x, put a parenthesis. And then now we're going to plug in a 5. 5 squared is 25, minus 20, minus 5 is going to be 0. So what we can expect is that if we did synthetic division on this and divided using the c as 5, our remainder would end up being 0. So with that in mind, a 0 of a polynomial is the number of a polynomial function p of x is a number such that when you evaluate it, you got 0, like in the last example. It says use synthetic division to find if it has the remainder 0, and also the 0 to see if 0 is a root or a solution to the equation. So basically when we evaluate these, if we get 0 as the remainder, we know that is a root or a solution to the original function. Okay, so 5 says, determine whether c is a 0. Basically what we want to know is if the remainder turns out to be 0, then we know it is. If it does not, then we know it's not a solution or not a zero. So let's test this at 2. So we're going to use the remainder theorem, and we have x cubed minus 3. Everywhere there's an x, put a parenthesis. Okay, and then we want to plug 2 in place of x. 2 times 2 times 2 is 2 to the third power is 8. Over here we got to remember to do 2 squared first, which is 4, times negative 3, which is negative 12, plus 8 minus 4, 0. Using the remainder theorem, we find out that the remainder is 0, so I would say yes, C is a 0 of the polynomial, 0 of the original polynomial p of x. And I'll just say of p of x. And they ask us to do the same thing with part B. They said, is C a 0 of this polynomial? So we're going to, everywhere there's an x, put a parenthesis, and then we're going to go back and substitute that value in and evaluate it. This time we're going to plug in a 1. Everywhere x is at, plug in a 1. So 1 times 1 times 1 is just 1. 1 times 2 is 2. 1 squared is 1 times negative 6 minus 9 plus 4. And I end up with negative 9. So I would say, since this number did not turn out to be 0, it means the remainder is not 0. Okay, so therefore, we would say C is not a 0 of p of x, or C is not a solution, or not a root. Those are all similar meanings.